Hello, everyone. How are you? You are doing fine? I do hope so. My name is Dinora. I'm Google Developer Expert in Android. Today, we are not going to be talking about Android. It's a different type of talk. This is your default talk for AI. So today, we are going to be talking about DataFrame. And especially, we are going to be talking about Kotlin. So this talk, even if you are not a data scientist, is going to be working properly. Because you're already an Android developer, right? And you probably are going to know a lot of this stuff is going to be something that you're really going to be able to catch up and start working. So this is more on-hand talk. So first things first. You know, I always do a disclaimer in my talk. I'm not a data scientist. I'm not a BI engineer or a data engineer. I just like maths, and I just like Kotlin a lot. So today we are going to be talking exactly about these stuffs, right? But I work for a data and AI company, so I know some brilliant data scientists that help me a little bit to shape this talk in a different way so you can enjoy it and I can provide the knowledge that I might like to provide. So with this disclaimer, get ready for it. So especially because this story is focused data and how data can be exploited. I know that probably all of you have tons of data in your mobile application, not only the databases, but the interactions that your users use when they are using your application, right? The analytics, the farmer analytics, the mixed panels, etc. And maybe you want to do some deep dive that this tool doesn't provide out of hand, that maybe you need to, I don't know, create an ETL to drop all the data from Mixpanel to a database so you can start doing queries on that area and understand how your users are behaving. However, with these talks, you can probably just do some other stuff to manage that experience, right? So first thing, we are going to be talking about maths, because maths are amazing. They are incredible. So the first part that we are going to be talking is that maths has some special qualities, right? And Kotlin is really nice to solve math problems. Because Kotlin is a fast operation language, it means it does functions faster than other languages. Kotlin also has an extended set of functionalities that give you the chance to do mathematical expressions on the code that we want to solve, right? We also have something that is pretty much similar to algebraic data types, which are sealed classes. Today, we are not going to be over that, but I have a specific talk about Kotlin and maths that is focused on that area, so you can go and search for it and see if you like it. And we also can do basic functions to complex functions, right? So let's see. Let's go over some examples. Today we're gonna see some code in Python. I'm so sorry for that. I hope you feel comfortable with your Kotlin knowledge. If not, it doesn't matter. Like, we are gonna be really fast. Let's see this code right here, right? This code here, it's a very simple code that does absolutely nothing. But this function takes 2.66 seconds, right? That's a lot. That code function is in Python. And this function is exactly the same function, but in Kotlin, right? We can read this. And this function takes only that in milliseconds, which means that Kotlin is at least 9 times faster than some languages that is using. Not only faster, but more efficient. If you are familiar with data scientists, you probably know that they use mostly 2 languages. One is Python, and the other one is R. So with Kotlin, we can solve some of the tasks that the data scientists are already doing, but with Kotlin, right? And one of the parts that today we are going to be talking about is the mathematical expressions and how we can turn that in code. Because to be honest, mathematical expressions are only something like pretty much pseudocode, right? So let's see this first function. This is a first-degree equation. It's pretty straightforward, right? This first-degree equation can be solved with a function in Kotlin that looks like this, right? Am I correct? Does it solve the problem? Yeah. You get a function, and you can return the value, and you can return a variable that is x, and you can solve it with that. And that's pretty much how you can solve a first-degree equation in Kotlin. Let's see a sum. A sum is a little bit different, right? When we see these kind of expressions, when we were in college or we were in high school, we ended up like thinking how we should be solving, right? In code, we might think a little bit more straightforward how we want to reach the functions that we want to do. So we can do something like this, right? Do a for, and do a sum, and do the factoring process, right? However, there's other options to do this. Do someone knows how to solve this little equation in a different manner? Shoot. Oh, that's a good one. Let's see. Well, I'm doing a sum and a map and something around those lines. But there is a lot of options, you see? Like in Kotlin, we have some diversification of the functions that we could use to solve this type of equations. And to be completely honest, this happens a lot when you are dealing with data. You need to do some summations, you need to do some factoring, for reaching a state for a model, you might treat first the data. And that's the most important part of this talk. Every good model has good data, data that is transformed, that is used properly, that makes sense. Bad data gives us a bad result of the model. I don't know if you were here on the keynote, but garbage in, garbage out, right? So that's exactly one of the most difficult areas when you are dealing with AI stuff and data science stuff. Most of the times, data scientists have to sit down to understand how they can figure it out the mess of the data, like clean it up, like trying to scratch all the data that might be giving you outliers or giving you like some aberrations on the data, right? Oh, it's pushing. Let's see this product, right? This also is part of one of the most classic mathematical expressions that we are going to see. And we can solve it with Kotlin. Like, we don't have to do a lot of stuff. Like, this is going to solve the problem, like, in a second. And we can also do functions that are pretty common in the data space that you might need to solve, like the average, the max, the minimums, et cetera, et cetera, et cetera. So let's see this array of data. And when we see this sequence, we can do something like this. We can do an array and push the average, the mean, and the max without doing thousands of lines or trying to figure it out how to do it. We can do it with Kotlin because Kotlin is a functional language. And not only that, we can also do multidimensional vectors. Multidimensional vectors are very commonly used when you are dealing with some certain type of data. So you want to solve these equations in a very specific manner. Sorry, this is going to be a little longer code, but you can do an array of arrays and go over every array and try to figure it out how you can do the resolution of the data. If you have basic math knowledge, because this code, this pseudocode we just saw, is very basic math, right? It's math that you usually learn when you were in high school, maybe in the first year of an engineering degree, etc. And you are already Android developer, so you can use that knowledge, use the past knowledge you have on math to understand how you are going to be manipulating data, okay? This is incredibly important because, to be completely honest and completely fair, Kotlin simplifies most of the tasks that we are going to see today. Second, let's talk about Kotlin, because Kotlin works everywhere. And when I say everywhere, you probably are going to see a lot of talks today and talks you saw yesterday, where we talk a lot about Kotlin and how Kotlin is very much now these days in every place that you might see. But first, let's talk about Jupyter in Python, because that's usually what data scientists are using, right? These two tools are the tools that the user are going to be using. OK, so this talk is full of like coding sessions. So let's see. I ended up doing like writing all the code and go over it. Because I got nervous, so let's see this. I don't know if you can see and read the code that is here. Do you mind me to make it bigger? Yes? OK, fine. So this code is in Python, right? Look, what you are seeing is PyCharm. It's not a Jupyter notebook. The only reason I use PyCharm is because I like it. But it's going to be working the same if you are in a Jupyter notebook. You can put a Jupyter notebook like just going over the website. If you go to Jupyter notebook site, you are going to see that there are many examples. And you can try Jupyter Lab inside your browser. So when you enter this area, you're going to see some kernels that works and some utilities that you might want to use. If you want to try and start doing things in Python and Jupyter, you just go to this website, and it's going to throw you that Jupyter notebook example that is pretty much the same that you are going to see in the code I'm just showing. Not the same code. They do something else here. Here, you're going to see something very much similar of a Jupyter notebook. Because this, my friends, is actually a Jupyter notebook. It has the same extension, the file, and you can run code in little cells. A notebook executes cells and give you the answer. So every time you run a cell, it gives you allocates that results and the variables that you ended up doing in that cell, so can be used for consequences cells, right? So, for example, if I decide to only run this one is already running, sorry, I'm going to be able to run this cell without having to run again this one. So it's going to give me the information that we are going to use. Today, we are going to be using a huge file that has 1 million records. I don't know how familiar are you with a tax system in Mexico, but today we're going to be using 1 million records from the tax system here in Mexico. This information is going to be very interesting. Let's see what it gets. It has some IDs, some tax identifier, the type of that tax file, et cetera, and you can get a lot of information from here, right? These 1 million rows, it's very difficult to manage in Excel, right? Millions of companies are doing this information in a simple Excel. However, you can start doing it with your knowledge in Python or your knowledge in Kotlin. So if we are already here. This is very straightforward. If you know a little bit of Python, what we are doing, we are importing some libraries, which are Pandas. Pandas is the most common library that data scientists are using. And we are also using Matplot library, which is just pretty much a library for doing the plots, right? And what we are also doing is that we are going to be accessing the file, the data CSV file that we have here. It's on my desktop. It doesn't have nothing interesting. If I click it, it's going to take forever to load because it has 1 million rows. It's going to be insanity. So we are not doing that. As you might notice, there is some null values. There is some values that are strings, some values that are integers. And we can also get the information of the columns that we have. For example, if you notice this part, you're going to see that we have some columns that have some rows that are fully with data. There's no nulls in that files. However, if you see this one, we see some nulls that might be causing us some issues, because why would I have that set of values with null values, right? We can see some of these here, some of columns that are always null, and we can go over this in a very easy manner when we are using Jupyter and we are using Jupyter or we are using Python. Right, give me some other information. I'm asking for the unique values of the data in some specific column, and once it returns, it gives you the values of the counts that we are going to find. So it's going to be the records of the data. And finally, we can also do upload, because sometimes we want to just do a little chart. And it's going to show you some data that is very interesting, and it's going to give us a deep down of how we are seeing the data and how is the count of the rows for the data. So that's Kotlin, let's wait for it. So the only thing I want to show you is that we're going to do something very similar today with Kotlin. And it's going to be a little more easy. And we're going to do something else, right? So yeah, we already see this one. Sorry. So going back to Kotlin working everywhere, we already know that Kotlin works across mobile platforms, right? We also have server-side on Kotlin. Someone has ever used server-side code in Kotlin? Oh, some hands. Nice. It's really pretty, to be honest. We have Android, that I believe the majority of us have been using it. We have native code that can be used for iOS and other stuff, such as we also have web development. That right now everybody's very focused on mobile and Kotlin multi-platform and Compose multi-platform, and how we can do it for web development and how can we do it for iOS. And finally, we have another one, which is data scientist, which is actually more focused on data implementation and how data is managed. Let's talk about one of the most important parts for a language to be able to run Jupyter notebooks is actually the kernels that we have. So in Kotlin, we have a kernel for that. So let's see some examples, right? So we can do Kotlin notebook. We can do a Jupyter notebook. And we can also use another set of tools that might have the power to run code in cells, in code that might be able to execute some data transformations. And these three little friends sends the code. And once it sends the code, we get the Kotlin kernel, the Kotlin compiler, and the Jupyter notebook, right? These three friends do different stuff in different times. The first one, the Kotlin compiler, executes the code. However, the Jupyter notebook is the one addressing the results and the changes that you are going to see. So that means that this kernel layer is the one that is going to be able to give us chance to run a Kotlin notebook inside our IDEs like IntelliJ, right? So let's see this little code, right? Oh, sorry. DataFrame, this new library that we are going to be seeing, that is not so new, can execute code in classes. I don't know why it's skipping, sorry. Let's focus on the code, okay? So you probably know this code, and you can use this code, open it and IntelliJ, putting the plugin in Kotlin, in the Kotlin Jupyter notebooks, and you are pretty much ready to start running the code. So in Kotlin, with DataFrame, you don't need to install a Jupyter notebook, okay? That's one of the first things I want to say. You don't need to install anything else, only a Gradle library, and having IntelliJ in your computer, and you are ready to go. We're going to see how this works, because there is also some situations you might want to execute code that is based on cells. Because you are doing a fast analysis, because you are doing something very specific that is only a task that you want to do, like checking some data, right? It's not a process that might be indented in classes, in functions, that you might want to address. You can also do it using cells, right? And this also makes possible to have accessible code on REPL with Kotlin, right? I don't know if you have ever heard about this. We are doing a live coding right now. So let's see. This is Kotlin, right? So let's see this Gradle file. Inside this Gradle file, you're going to find two libraries that we are going to be using today. The first one is DataFrame. As you notice, it hasn't reached like a stable version. And we have the CSV file. That is a new library that is going to give you a chance to open the CSV that we are going to be using in 1 million rows, right? So these are the two libraries, the most important two libraries that we are going to be using today. If you want to start using DataFrame, these are the libraries that you might want to use. There's some other libraries that are public that has the same name that DataFrame. They are not the correct ones. So if you want to start using DataFrame, this is the one you are going to use. And this project is a very simple project in Kotlin. It doesn't have anything else. If you see, it's very simple. There is nothing like different as a Kotlin project, like setup of a project Kotlin. So let me show you one of the first things that we are going to see. Okay. So if you notice, this is a file that has an extension of Kitty, right? Which is Kotlin. This is the same extension you have in your Android files, correct? However, what we are going to do here is not Android-based. It's going to be class-based and function-based, but it's going to be a little bit different. The first thing we are going to create here is we are going to create two objects. The first one is basic info, and the other one is full info. And as you might notice, we are going to be able to run and execute code using this area, right? We also can do it based on these cells. And it's using the same library. I think this is a little bit too small, right? Oh, I cannot do it bigger. Oh, my God. Oh, I hope you are seeing this. Can you read it? Yeah? OK, great. So as you might see, on the first line, we are going to be using the same library that we be using in a simple, normal file. So what does it mean? We can do data analysis on Kotlin with the function and the classes that you might feel comfortable, but also with just a notebook. So it's your choice how you decide to do your Kotlin review, your Kotlin data exploration, right? It depends. It depends on what you want to build and what you want to create. Sure. So we are going to be talking about DataFrame, as you might already guess for the name of the talk and for the code that we have been seeing. Because DataFrame is this new library. It's inspired by one of the big libraries with data manipulation, and this is Pandas. You probably have heard it or not, but Pandas is pretty much used in every data scientist process. It's one of the most common ways to clean up data, make sure the data is standardized for the purpose, maybe creating a new data set specific for a model with specific values and creating new columns. This is the library they are using. And DataFrame is inspired by that. It's inspired by Pandas and has some of the same functionalities that Pandas has, which is that is generic, it has polymorphic accessibility, and is interoperable. And we're going to see some of these cases, right? So if you remember, we were seeing code in Kotlin, right, in classes, in functions. So let's see this enum. Like this enum has only the temperature units, and we have a sensor that is reading that information, right? Sorry. An object here can be as complex as we want, and can be the CML of a database. Can be the CML of multiple databases. It depends how you want to build it, how you want to do it. So we can do a data class for the information that we want to have, and we can store values in that data class, so we can do the data manipulations that we might require and we might need, right? This is very important because not a lot of, if you see the process of a data analysis, the data analysis is going to happen only on a notebook. And that is going to give you some tricks and parries that you might need to solve to put the Python environment running, to put everything in order, like installing all the pips that you might have. And with Kotlin, this is pretty much removed with just using the DataFrame library and doing the implementation, right? So we also can have these classes, which, to be completely fair, these solve a lot of the problems that we might have with managing data. We also have a iteracy in our data schemes. If you see this code, fall info is using the interface of basic info, right? That means that we are also be capable to use that for the data manipulation and the data processing and the extraction of the data that we might require, okay? This sounds like a simple task, like something that should be out of the box in many, many languages. But to be completely honest, this doesn't happen like this. If you see, there is an annotation that says that it's going to be a data schema. See, if it's a data schema annotation, it's going to be able to be used in DataFrame. And we can do some tasks like this, right? We can add some data to the objects that we were seeing. Today we are just adding some values, some names and ages, some names and the cities. And now we can start doing polymorphic simplification and try to print some data of the information that we might have, even for full info or basic info, right? And there is something really interesting about DataFrame, because you can use it with Kotlin files, but also notebooks. And it's fully interoperable. So we can do data classes that can be used in data frames, right? So if I want to, let's see this code, right? So this code is for a Kotlin file. We have a data class that it has an author. We have another data class that has the books. And we are initializing that variable with a list of books and a list of authors, right? This is a complex object that can be in a Kotlin regular file that you have in your repository that is the data that you might want to address. And inside Kotlin notebooks, we can do a full reference to that class using to DataFrame. and make it interoperable. So you can have a mixture of the Kotlin notebooks with all the functionality and all the process that you might want to do. And we can also have a full Kotlin file, like the regular Kotlin file with your data classes and can be accessed both ways. So that's really, really important because that doesn't happen everywhere. So let's see how it goes, right? So I was telling you that you can use these data schemas, these interfaces, to declare an object that you're going to be able to use inside a Kotlin notebook. So let me open this Kotlin notebook on the side, okay? So if you notice here, these two first cells is using DataFrame, which is the library that we are talking today. And the second library we are using is Let's Plot. Let's Plot is pretty much a library that does like charts. And we are declaring an object, okay? The object is the attenders of Android makers. We are putting the name, the email, the job, the age, and the ID. As you notice here, I'm gonna remove this code. Let's run all this. So as you notice here, I'm running the first cell. This is gonna take a while. We are running the attenders, and we are, forgot to print. Okay, let's do this again. So this right now, this data frame is using an interface that is allocated in this file. And this data frame only has my name and my work email. I don't know what it was. Oh, it's okay? Okay. And we are just doing a cast and printing out. However, I can add another cell. Name and age. And we can add excellent. And we are doing a cast. We are going to do a cast, but not to Android Maker. We are going to do it to basic info. As you notice, this variable is not located in the same file, right? Not even in the same folder. Like, this is where a Kotlin notebook should live. And the Kotlin file I have is living right here, like all the way here. However, it doesn't matter. It's going to find it. It's going to do the, told you you have to laugh, guys. I told you that. Just give me 1 second. Sorry, I need to run this one first. Because it doesn't have the reference that might be created in the past. So we are running that. Okay. Oh, it's not going to be able to reference? Why? Okay, so it's not going to be able to reference. Just give me 1 second. I'm going to need a build, but you're going to have to believe me in this one, but what it's going to do, because I need a build, but I don't want to do it right now. It's going to mess all the other code. It's going to show the results that we are going to see. So while you're going to trust me on this one, you're going to be able to use basic info that is in the data schema that we are seeing. If you want to, and you feel comfortable with your Kotlin knowledge, you're going to be able to do this information and this type of a structure in your Kotlin file without being, we don't even be required to do like a Kotlin notebook. And if you see this one, you are going to be able to see the values that we are going to have, right? We are telling them that we are going to print the names and ages. That is going to be based on basic info and basic age. And we are also asking them after that prints the same thing, but for the other variable that extends the first value that is basic info, right? So it's going to be able to do that, and it's going to throw the names in the edges of this data. And finally, we are going to be able to print the last part of the info. If you go inside this and you click this, you're going to see that DataFrame offers a set of functionalities that are out of the box, right? That we already know when we are maybe iterating inside an array and other things like select, rows, the column names. Like if we decide to print this, it's going to be it's going to be showing. I should just go over this. This column.print. Sorry. Excellent. So it's going to show the data, and it's going to give you the string. It's going to, well, it's going to give you the column names, and you are going to be able to get over for each and then be able to print it. Now it's going to show, sorry. I'm just imagining that my data set is going to be a linear data set, and it's not going to be that one. It's very, very different. So this type of data and this type of information is going to be able or enable you to do this implementation, right? And there's something else I want to show you. If you are using IntelliJ, you probably have this little menu, and you are going to have Kotlin, and you are going to have this experimental version. I don't know if you have ever used it. I don't use it often, but it's very common. It gives you a chance to run code here. It gives you chances to do some specific task. I should have not updated my GBM version. Well, if you open your IntelliJ, you're going to find it, and you're going to be seeing it. I just wanted to show it, but let's see now the code inside a Kotlin notebook, right? This is Kotlin code. We are not going to do something really different. What we are going to use, what we are going to see is that we are going to have two libraries, DataFrame and Let's Plot. Inside of that, we are also doing an importation of the file. And the only reason I'm doing this is because we are accessing my desktop and the desktop path to reach data CSV, which is, remember, 1 million rows. So once we want to do this, we are going to run this file path. I knew this will happen. I didn't check my memory here. I'm running another process and it's taking everything off. Just give me 1 second. Perfect. So let's run this code. So it's already importing the information. We are also seeing that has successfully loaded 1 million rows and 54 columns. That's a lot of data, right? If you do multiplication, it's going to be thousands and thousands of rows. As you might notice, we are taking the first 10 values that are available. There's a lot of columns. A lot of them has null values. Some of them are currencies. Some others are doubles values that also has null values on them. We are also having strings. Some others that should be populated, but they are not. Like this one, this should be always populated. And we have dates, like timestamps, that give us the information of what is going on in that row, right? And the second part that we are going to do here is that we are going to be over every column that we have, and we are going to be printing the name of the column, and we are going to be printing the values that has null values, which is incorrect. This is incorrect code. We are going to do something else for that, right? And here's the important part, we can do a lot of stuff with the information that we want. We can take only the columns that we might need. We can, like this one, that only takes the column owner RFC. We can also decide to take multiple columns, like if I decide to go and just take this head 10 dot just give me 1 second. I think this is gonna print it. If I decide to go this, it's gonna just cut the data set in only the columns I might need. It depends on what you want to do, right? For this one, we are only getting the ID, the owner RFC, and other columns that we might need. It depends what you want to build. It also has many type of filters. Like, let's see what is you can do. You can go over the column names. The columns, you can select some columns, the rows that are based. You can sort the data in the matters that you might want to find. We can take an index depending on what we want to do. These are another areas. We can aggregate. We can get the column types that we might have. We do an iterator. We can do the run counts. We can do a lot of stuff here that you are probably thinking, this is the same things I can be and can do with arrays, right? And with lists that might be available. It's nothing like really shiny, but it is because we are talking about 1 million rows with 54 columns, right? So we can do column groups, column as group bys, association, chunk it of the data. We can combine, compare, copy. We can do summations, descriptions, et cetera, et cetera, et cetera. And we can also do the mathematical expressions that we saw before, right? So there's a lot of things, like we can do the filter for just a specific data type with a specific data column. As you notice here, the columns that I have in my data set are already populated. I can reference the name of the columns right away. In Python, it's a little bit different. You have to go over like quoting system to tell them that that's a column. However, in Kotlin, that's not the case. Kotlin knows what columns are indented in the data. And you can also drop any nulls that we might have, right? So one of the things that we saw here is that this value that I was telling you about should not have values that are null. Let me see if I find the column. This one, no, is not it. I lost it. No, it should be here. I just don't remember the name of the column. Receiver. Oh, here one. This payment method. As you see, it has some nulls. We don't want that. That doesn't exist in Mexico, like in the taxes system, right? That doesn't exist. So you can go over it and say, okay, like we are gonna do is we're gonna try to clean up that data set. Gonna do df.drop na when is a payment method. You see, it's auto-suggested by it. Head 10. So what we are gonna do here is that we are gonna we are gonna print cleanup with head. That is gonna be only the 10 first values with the name of the row. And we are gonna see that this column that we were just checking out is no longer has any nulls. I'm pretty sure that is not gonna have any nulls unless the first rows that we saw that they have nulls, right? Oh, Jesus, this data set is so weak. Payment condition, payment method. So payment method used to have the first 10 rows, used to have some null points. Now it's clean up. It doesn't have these ones. It probably is not even the same ones, the same IDs that we used to have because we ended up cleaning up that data set. And I know we are over the time, but what we can do is also go and do a count of the distinct owner RFCs that is going to be our main primary key. And finally, because we are running a little bit of time, you can also do queries of the plots and the data that you want to do. So with Let's Plot, you can cut the data set, group by the count, and just push the data of the, oh, this is looking awful. Just give me 1 second. You can push the data, and you are going to be able to showcase a little graph with the totals of the values that we already saw before, right? We can also do a summation if we want to showcase the total amount, and it's going to show like, these are the values that we are going to see in the users. So imagine now that you are be able to do this with the data of your analytics, with the knowledge that you already have with Kotlin, to simplify some of the tasks that you might be doing with data analysis. Don't leave all the tasks to the data scientists or the data engineers. Data is here to be exploited. So my name is Dinora. I'm Google Developer Expert in Android. We are already on time, so if you have any questions, I'm going to be outside. We can chat about it. I really appreciate that you show up. Thank you so much, and have a nice day.